Chapter 4 is called Matrices and System of Linear Equations, and we're gonna have 4 subtopics. So let's start with subtopic 4.1 Matrices. And in 4.1, we'll be learning about types of matrices, properties of matrices, and also transpose matrix. So, what is a matrix? Basically, kita boleh tulis dia macam ni. And then, kan kat dalam ni kita boleh letak benda-benda ni kan. This one, kita panggil dia sebagai entry ataupun element. And for matrices, you can use square brackets or you can even use normal brackets. They are the same. Alright? Masuk dia masih lagi matrices. Just make sure kamu gunakan square bracket ataupun normal bracket, bukannya modulus. This one salah. And each matrix will have their own order, which is m by n. Okay, so apa maksud m by n ni? Basically, kalau kamu perasan, matrix this one dia tak sama dengan matrix yang lagi satu ni. Beza dia adalah, this one dia ada 2 row. 1, 2. Ini pun 2 row juga. 1, 2. Tetapi, untuk yang sebelah kiri ni, dia ada 2 kolom sahaja. 1, 2. Yang sebelah kanan, dia ada 3 kolom. 1, 2, 3. Okay, so sebenarnya setiap matrix ni dia akan berbeza dia punya row dengan dia punya kolom. So, daripada situ datangnya kita punya m by n. So, m kat sini always baca untuk row, n kat sini always baca untuk kolom. So, kalau kita tengok yang this one, that will give you the value of m, and this one will give you the value of n. So, bolehlah kamu baca setiap satu matrix tu apa dia punya order. So, let's say we have matrix A, which is 1, 2, 5, negative 3, 4, negative 1. So, what is the order for this matrix A? So, how many rows do we have? 1, 2. What about the columns? We have 1, 2, 3. Therefore, we know that matrix A is a 2 by 3 matrix. Another way of writing the order is, you can straight away write A and then we have 2 by 3. So this means that you already know that this matrix A has 2 rows and 3 columns. Let's learn about types of matrices. The first one, we have a row matrix. Okay, so apa maksud row matrix? Row matrix ni maksudnya kamu cuma ada satu row sahaja. So, instead of m by n matrix, sekarang row kamu satu dan kamu akan ada n column. So, that's why we're gonna have 1 by n matrix. For example, if you have matrix A equal to 10 to negative 5. So, here we can see that we only have 1 row and we have 3 columns. So, this matrix A is 1 by 3 matrix. The second one is called column matrix. So, column matrix maksudnya dia cuma ada satu kolom sahaja. Okay. So, instead of m by n, sekarang ni n kolom ni dia jadi satu. So, that's why we have m by 1 matrix. For example, if you have this matrix A equal to 21, negative 1, 3. So, we know that matrix A is a 3 by 1 matrix. The next one is called square matrix. Okay, kalau square maksudnya bilangan row dengan bilangan kolom tu sama saja. So that's why we're gonna have m by m matrix. For example, if you have A equal to 0, negative 1, 2, 3. So you can see that it has 2 rows and 2 columns. So it is a 2 by 2 matrix. We can also have matrix B equal to 1, 1, negative 3, 2, 5, 10, half, 4, negative 7. So we can see that it has 3 rows and 3 columns. So we can write down B 3 by 3 matrix. The fourth matrix is called zero matrix. So basically, kalau nama dia zero matrix, ini maksudnya semua entry dia adalah kosong. For example, this one, P is equal to 0, 0, 0, 0. And we know that P is a 2 by 2 matrix. We can also have something that looks like matrix Q. So in this case, it is only 0, 0. And since it has 2 rows and 1 column, so this is matrix Q 2 by 1 matrix. For diagonal matrix, only the leading diagonal entries have values. Maksudnya, kat tengah-tengah tu saja yang ada value. Okay? All the other entries are 0. Maksudnya, kat tengah-tengah ni ada value, tetapi yang kat semua yang kat sebelah kiri kanan ni, semua tu adalah kosong. For example, we can have matrix M equal to A0, 0, 2B. So you can see that only the leading diagonal have values. Kat tengah-tengah ni sahaja yang ada value, tetapi yang lain-lain semuanya kosong. And this matrix M is a 2 by 2 matrix. We can also have matrix C, which is 1, 0, 0, 0, 2, 0, 0, 0, 3. And you can see that only the leading diagonal have entries. Other than that, all the other entries are 0. And you can see that matrix C is a 3 by 3 matrix. The next one is called identity matrix, where all diagonal entries are 1. Maksudnya, kat bahagian tengah-tengah tu, semua nilai dia adalah 1 dan all the other entries tu adalah kosong. Maksud semua sebelah kanan dengan kiri adalah kosong. Untuk identity matrix, identity kan start dengan I kan? So, kita punya simbol adalah I. And identity matrix is only for square matrices. For example, if you have identity matrix which is a 2 by 2 matrix, which is 1, 0, 0, 1. And you can see that all the leading entries are 1, but all the other entries are 0. So this matrix has 2 rows and 2 columns. That's why it is I 2 by 2. What about identity matrix which is 3 by 3 matrix? So it is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. All the leading entries are 1, but the rest of the entries are 0. The last type of matrix is called triangular matrix. And this matrix is only for square matrices. So, tengok nama dia triangular kan? So, dia akan ada bentuk segitiga. Bentuk segitiga dia mesti like this one ataupun this one sahaja. Bukannya bentuk piramid ya, itu salah. Dia mesti bentuk right angle triangle. For example, if you have matrix A equal to 1, 0, 0, 2, 6, 0, negative 1, 5, 4. So kat sini kamu nampak kata kat bahagian sebelah kiri dengan bawah ni sahaja yang ada value. Yang lain-lain dia kosong. And please take note that for triangular matrix, even the leading diagonal have values. Okay? Dia termasuk dengan yang tengah-tengah tu. So start pada tengah-tengah ni and then dia pergi ke bawah. So kamu nampak kata this one dia ada value kan? Tapi yang kat tepi-tepi ni dia tak ada value kan? So bila dia pergi ke bawah, ini maksudnya dia adalah lower triangular matrix. What about this matrix S, which is 1, 2, 3, 0, 4, 5, 0, 0, 6. So kat sini kamu nampak dia punya leading diagonal dia ada value and then dia naik ke atas. So dia naik ke atas ya. So bila dia naik ke atas, ini adalah upper triangular matrix. Therefore, matrix S is an upper triangular matrix.